All right, so let's get this problem up on the screen here. And in this table here, it shows 24 cookies, how they can be divided equally among different numbers of students. So we have numbers of students along the top row and number of cookies along the bottom row here. So what we're asked to do is determine whether the relationship here is an inverse variation. So I'm just going to actually change pens real quick because I don't have the one that I like. And I'm going to use that formula k equals the product of x and y. So as long as our product of x and y is constant, as long as we get the same value for k each time throughout this table, we're going to have inverse variation. So I'm going to think about the number of students as x, the number of cookies is y. I guess that's not necessarily important right now or too important, but I can just actually, I could write it off to the side here as 2 times 12. In fact, I don't want to do that either. What I'm going to do is just consider it as multiplying straight down. So just 2 times 12 will give me a value of 24, and 3 times 12 will give me, or 3 times 8 in this case, will give me 24. And if I move along this table here, as long as I'm multiplying, 4 times 6, as long as I keep taking the product, I'm going to get 24, and 24, 6 times 4, and 8 times 3 will give me a product of 24. And I'll finish these symbols off too. Okay, so each time the product of x and y gave us a value for k, and k was always equal to 24. Therefore, this relationship is an inverse variation. Notice here, as the number of students increases, as x increases, the number of cookies that each student gets decreases. So as x increases, y decreases. Let's take a look at another problem. All right, so let's take a look at this next problem, and again we're going to look at it as k is equal to, not y, as the product of x and y. There we go. And in fact, what we're looking at here is this table shows the number of miles jogged given a specific time, or given a time here, and we want to know if this is an example, or if this relationship is an inverse variation. So does this example show an inverse variation? And let's just think about it logically before we even do this math. Well, the more miles that I jog, or the more miles that you jog, you would probably think, unless you're getting exponentially faster as you run, your time's going to be longer as you run. So I'm just assuming here that this is not going to be inverse variation. So let's think the miles jog. So what I could do here is, again, I'm just going to multiply my x value by my y value, and that will give me, this will equal, we'll just write it funky this time, so x times y, x times the product of x and y here will give me k. So let's find out what k is equal to. So when I multiply 1 times 8, I'm going to get 8, and let's go to the next one, 1.5 times 12. When I multiply 1.5 times 12, I'm going to get a value of 18. I can already see that the value for k here, it's not constant, it's not the same. Therefore, this is not an example of inverse variation. Again, if you don't want to use 1.5 times 12, maybe you want to use some easier math, you could have jumped all the way to the end of the table and just multiplied 5 times 4, which would give you 20, and then just add that 0 out to the end. And here we see that k is equal to 200, and we could compare that to 8 or 18, I guess, if you wanted to, and just say, well, no, none of these are the same, they don't match up. K is not constant in this table. Therefore, you do not have inverse variation. Cool, I'll see you in another video.